Thank you, thank you. I've titled my presentation Deployed Machine Learning for Everyone, which I will get into. But first, a short introduction of me for the faces I don't recognize here. My name is Erik Munkby, and I'm here today to share and inspire as all of us. But apart from talking data and talking code, you can always talk to me about skiing and sailing. Those three together are my three primary passions. The top one there is from Engelberg in Switzerland, and the bottom is from a midsummer competition that we participate in every year. But let's start with this quote. I think a lot of you have seen it before or heard it before. But it says that more than 8% of machine learning projects fail to reach production. And I did not put it here to be inspiring. I put it here a little bit because I don't really like it. First of all, today I learned, so you can quote Ben on this, not me, but that can also be applied to most other projects as well. It does not only talk about machine learning. And the second part is that it's very vague in itself. If you start a proof of concept and try something out and you realize that this test or what we're trying to do is not a good idea, do you then consider that a machine learning model that did not reach production? But an example stack of trying to get machine learning production can look a little bit like this. Some people here will recognize this stack. But we have somewhere where we build the models or train the models. It could be Databricks. For those who don't know Databricks, it's a cloud-hosted notebook platform with Spark in the bottom to power it. It can be something like MLflow for model tracking and model packaging. It can be something like Fast API for then, building an API. And it can be something like Docker and Kubernetes for then serving this API. And this works pretty good, but there is already a couple of steps here. Right now it's 4 steps. And MLflow especially works really well for tracking it, but I like to call it, I really like MLflow, but I like to call it a glorified file system handler. It's pretty much just in a nice UI letting you know where all the different versions of the models are and not letting you overwrite old stuff. So if you do some, you can probably write a pretty good file system handler for that yourself. But if we start breaking it down a little bit more, so the original goal is take it from some kind of finished trained model and want to put it out so that we can use it in the greater cyberspace. But then what usually happens is that you stumble onto, it's not only this step, there are more things we need to involve. And one of the first things that I think a lot of people recognize is some kind of business logic. So usually, depending on which framework you use, but the model outputs some kind of float maybe. And you can't just send back a float a lot of the time because the other systems, then you need to put the code in those systems instead. But somehow you need to couple a business logic with the output of the machine learning model. And usually then, before the model receives the input, you also need to pre-process a little bit. So in some cases, you in the development or the production environment, you're working with a lot of string values. And the model you've chosen cannot really use string values. You can only use numerical values. So then you need to have some kind of encoder to swap those string values out. And then you need to make it accessible because most machine learning models aren't APIs by themselves. So you need to put it into some kind of API, or you can serve it in other cases, but API is very nice way to do it. And then you also want to build some kind of documentation for it, and you probably want some hints as well so that developers who use this don't have to have you by their side anytime they build a new query that's going to use it. And then you want to, like we heard in Johan's talk, we probably want to containerize it. so that all the dependencies are correct and that the environment it's running in is not dynamic, but we can trust that it will give the same output that we had when we were training. And then maybe we want to serve this model as well. So we put this containerized application somewhere in Kubernetes, for example, and this list can go on and on. I mostly got tired of copy and pasting and building these blobs, so I stopped here. But there quickly becomes a lot of steps to serving something. So even though I don't really like this quote of a lot of models don't reach production, I think some parts of it is that an organization is new to this and haven't really done it before, so there's a lot of parts involved. And I like this analogy of an axle. So if you have a stick and you try to move the stick in one end, you get a reaction in the other end. If it's a straight connected stick, then it's going to mimic all your movements. But for every axle you add on this stick, the stick becomes increasingly harder to mimic the movements. And we have the same thing here, that we have a lot of different isolated topics or parts we need to take care of. So, yeah, fuck my life, right? And another small anecdote. I don't know if you heard about this. It was a pretty controversial topic recently, but there was a guy who entered a contest, an art contest, with an AI-generated image. So I wanted an image for Fuck My Life, and I used the same software. It's called Midjourney. It's very fun to play around with. I noticed that the F word, I used what do you have, one F-bomb per episode, and I use 2 now, so I think this will be in the US. Rated 18, yeah. That is also a banned word in Midjourney. So I didn't write F my life. I wrote something in the lines of life is over on this planet or something. And this is what the software returned. But coincidentally, so I said in the beginning that I love coding. So I also do a lot of coding in my spare time. I mostly have some kind of hobby project I'm toying around with. And the most recent one is also, the working title is FML, for fast ML, which is an occupied keyword on PyPy, so I can't use it, but it's the working title. And it has 2 primary objectives, this open source package that is going to be, and it's reduce the number of disconnects from machine learning to production. And I show you this chain link before, so make the number of links in this chain smaller. And the second one is to, like my presentation is titled, to enable more people to deploy machine learning. And I can tell you now as well that my goal of this entire presentation is to have some of you guys tell me that what I'm trying to do is a bad idea, so I don't have to spend time more on it. So, in other words, don't hold back on any critique. That's what I'm looking for. So think of it like an, what do you call it, a disposition, opponering. Yeah. So the parts I'm trying to work with is from, you have some kind of finished machine learning model. So the training parts that I don't want to deal with, that you can do whatever you want to, because there's so many ways to do it, to combine all of these yellow links into one. And now it's time for demo. So it's the first demo of Data Alliance. So as usual, pray to the demo gods. But in this demo, I use the Palmer Archipelago Antarctica penguin data, which is a super cute data set. Some people call it the cute version of the iris data set, but you have 3 different species of penguins with data about the penguins. And for the demo, I've chosen to use the random forest classifier. So we do a bunch of imports, and then we got this penguin dataset, and here you can see a snippet of it. Here you see one of the species and the different different data points collected about each penguin. And the culmen is the beak. So we got the culmen length and the culmen depth, the flipper length and the mass and the sex. And just to start off by checking out the data, I'm not going to write any code, only some CLI commands. So hopefully everything works just as it did 3 hours ago. But we notice that we have some nulls, we have a sex that is a dot, and we see that the island is highly correlated with the species. So I've decided to just remove all rows with any null values, remove the sex that is a dot. I've dropped the island column because it didn't seem so fun when it was so correlated. Built a sex encoder to get rid of the string values. Since random forest only takes numerical values, and applied that sex encoder. And finally, by the way, it's completely fine to stop me if you have any questions, or I'm going too fast at this point. And finally, we just split it into a training and validation set. We try out this random forest that I made pretty dumb for random forest, so we only have 3 estimators and they can have a maximum depth of 3. Otherwise, it seemed pretty easy to get 100% accuracy on this dataset, even with the validation datasets. And then we get into the FML part. So FML as a library, I have 3 primary components. And has anyone worked with Fast API, by the way? I know at least a couple. Yes? So it's using, later when we build everything, it's using Fast API. So I mimicked a little bit of the Fast API syntax. But we have the FML class, which we want to inherit when we build what we're gonna deploy later. We have the decorator for creating endpoints in our API, and we have the packaging tool. So first of all, I talked about tying the business logic and the pre-processing in together with our model. So we got some kind of init function. And here we input both the encoding dictionary as well as the columns that we have, so that later when we send data to the API, we know to build the input vector in the same order as the model wants. We've got a setup function, and this one will be called immediately upon starting the API. So here we can do stuff like loading in a model. We got just a build input vector function. So this is where we build the input vector that we later send to the machine learning model. And finally, we've got what becomes our endpoint, which is a post path or a post method on the path penguin. We got some data input, and we build a vector from it, and we make a prediction, and we send some information back. And Fast API familiar people will notice here that I have not used Pydantic yet, and I will get into why in a little bit. But we ran all the other cells, yes. So we run this cell as well. And then we take the model and we dump it into just an artifact. And joblib is the scikit-learn recommended way of dumping models that work with the NumPy vectors. You could instantiate the entire wrapper with the model as well, but that can sometimes, depending on the library, have unwanted results. So it's best to use whatever packaging tool the model supplies themselves. So instead, we include that as an artifact. But we do instantiate with the other meta information we wanted, because that is pure Python. And finally, we build this into a package. And we have a storage FML package at penguin.fml. So far, we've been in a Jupyter notebook and built a machine learning model, like I believe a lot of people here have done as well. But now either we build and want to serve it ourselves, or we send the FML file to someone else. So like I said before, MLflow is a glorified file system handler. And the reason it works so well is because everything has a file system. So that is why this works as well. Since if you have cloud-hosted notebooks, maybe you don't have direct contact to Docker, for example. You can only work with what they allow. So then let us instead hop into the terminal. So this library also functions much like Kuwait is also a CLI tool. So starting off, we can see that we have our penguin.fml file here. So now we starting off like you can in Fast API. You can just serve this straight away, and you get a documentation page that lists all the endpoints that were listed. So here we can see the endpoint. It's a post function. It's under the path penguin, and the call is called species. And here we see the description we gave in the function. So that is just like same works for Fast API. But then what we probably want to do instead is to build it, so we can build it into a Docker file or Docker image, and then we can run it using Docker instead. So here I'm just port forwarding. I tagged it as FML demo, and then I port forward the ports that we're running it on, and we get the same page, but now we're running it from a Docker container instead. Yeah, so that is what I've been toying around with lately. And I said I would get back to the Pydantic part. So that is the first question I have for you. As you can see here, the data input is not as you would like it. It's just one string field, and that is not what I want as input. I want some actual inputs. So in Fast API, you do like this instead, that you use Pydantic, and you build a data model class via the Pydantic library. And instead, you just tag this as the, or type this as the input of the data. And same way, you can also add a response body, or response model, I think it's called. And you can add another response model, so you can let it know exactly how the data out will look like. But when I try to do this, I get the error that you cannot pickle Pydantic classes. Ooh, do you want the microphone?
I mean, you could do it ugly and just go dict and then initiate the Pydantic class from dict.
Yeah, that's not a bad idea.
Yeah. I was also thinking about, have you ever looked at either Deep Java library or Tribio by Oracle?
No, I have not.
I think both of those might be interesting to you. Both are based on the JVM though, but
Okay.
they are actually trying to solve the same problem that you're doing, I think, by coupling the model with all the business logic.
What was the names again?
Tribio, Tribio. Och sen DJL för Deep Java Library.
All right. Yeah, thank you for that.
think, yeah, you could find inspiration, I think.
Yeah. So just to show for the people who aren't familiar with the Fast API, this is what it. This is what it's supposed to look like when when you're using Pydantic to mix with Fast API. Then you will get instead this type of input examples. In the same way, you will get an output example showing you what the input and output will look like. So luckily, I built one version using Fast API, so I can show you what it looks like in action. So we have some kind of input. Now I'm only using the prepared examples. We click execute, and back we get the response that we predict that this is a penguin of the Gen 2 species. And it's successful, and there's no error message. So if we swap something, now it's apparently an Adelaide. So it seems like the males in the Gen 2 are smaller than Adelaide, if I can do quick head thinking. Yes. So that is it. If there's anything else you want me to show before we dive deep into the criticism?
Can you show the configuration part again?
Yes. You mean this here? Oh yeah, I forgot to mention as well. So there is also, to rebuild the same states, you can send in either just the references to the packages you imported, or you can send in, like you would in a requirements.txt file, send in the actual string. For since, yeah, you might do either. And then it will also fetch the Python version you were building or writing the code in to make sure you get the same Python version. Yes.
Are you gonna show us your GitHub, or is it open source yet? Or
no, it's still
repo that we can like.
Oh yeah, not yet. No, it's private since I want to find a name that I could actually publish to PyPy if I wanted to. And I'm struggling with naming things. Surprise. So no, not yet. But I will maybe post in Slack if it happens.
What do you think about the idea of supporting an open standard for model responses and requests, such as like KF serving or something, rather than just your opinion? Think that could like make it easier to adopt it.
Yeah, that's a good idea.
What was it called? Sorry?
KF serving, Kubeflow serving, the one good part of Kubeflow that doesn't like make you despair when you try to deploy it. Yes, and one more question, like, why would you put all this business logic into the model serving? Why not leave it up to like the caller to encode the penguin sex? Like, what if it changes? I don't know. What if there's a dot penguin sex at some point in the future? Like,
that depends on case to case, but from my experience, it's very easy that they drift apart, specifically business logic with the machine learning input-output. So that is why recently when I've worked with it, I've tried to keep those coupled together. But there are probably very good arguments for doing it the other way around. But specifically that it easily drifted without one part notifying the other parts. So then, yeah, much like you do with states, just lock everything together, and then there is no way it can happen. But that also does make it, if you want to make some minor fixes, if you just, I mean, if there's, like you're saying, if there is a new sex, then I guess now we have to retrain it anyway. But if it was just incorrectly flipped for some reason, like there was a bug in the code, now we would have to maybe not retrain, but at least redeploy the entire package that included the model as well.
Yeah.
That in some cases could be cumbersome.
I see your point, but I guess that would be my since you asked for criticism, that would be
Yes.
my criticism that
Thank you.
You created such a clean and nice interface, but by allowing for all this business logic to invade that, you make it really vulnerable to all these changes rather than just saying, here's my model, this is its spec, if you want to call it API, this is how you talk to it, figure out how you translate all your needs into what it accepts. I would find that a cleaner interface, but I also see your points. I don't know. We can debate this.
Yeah.
Any other points?
I can almost see it, but not fully. Like, what would be the intended workflow? Like, how would I set up my CI/CD? And I didn't fully follow along where everything, how it would fit together.
Yeah. The rough idea is that you generate these FML files, pretty much, which are everything you built here bundled together that you then later can build a container from. So in here, you need the FML package in the other place. You're spinning up an image from the FML file as well. But the idea is that where you are writing your machine learning code, you maybe not have a Docker system, so you cannot immediately package everything into an image. So you instead generate these FML files, and then you would then have to build your own versioning system of the FML files. So like not trying to do what MLflow does, that you can solve yourself in your best way. And then you can either dump the FML file somewhere or send it somewhere if you have a blob store of these FML files. But then another entity, or maybe you yourself just in another environment, can take them and turn them into images and spin them up somewhere.
You mentioned that. I think that's where I got a little bit stuck. Like, how often would you create these files? Like, how often would you update your models? And maybe versioning is something you would want to incorporate into this. Maybe some way to do that smoothly. I don't know. But I guess it's a connection between retrained model and initiating it. Like, because getting everything working afterwards seems super smooth. But like, how and when and why? No, how and when would you connect those two? Like from trained to actually kicking through the whole process, I guess. Yeah.
Yeah, I do not have an answer for that.
That's okay.
Yeah. But yeah, versioning is a good idea to make part of it for sure. I mean, I think MLflow mostly works with unique, like generated UUIDs, and then just keep track of those and make sure that you can't update an already existing UUID. Then you get a new number, and something like that is not maybe not that difficult. But there is, I saw another package while researching this a little bit, and I don't remember the name now, but they also had, they did a similar thing, but they only had two predefined functions or API calls. One was predict, it was only called predict and couldn't rename it, and the other one was called train. So something you could do. Sorry? No, that doesn't ring a bell. But something you could do would be then to add another endpoint. We call it a post method as well. And maybe we call it on an update, and then we add just a train endpoint. And then we just take our self.model and then we fit it to more data. So you could, if you want to do some more frequent online learnings, and then eventually you come to a point when you want to retrain the entire thing and redeploy it. But you could build yourselves opportunity to retrain without going through the entire process again. Yes. Any other questions?
Is there any way that models are not in your file path? That is, that you have some kind of storage somewhere where you could swap out the model?
After it's been deployed? No, not.
So it's only path-based right now.
Yeah.
Okay.
Exactly.
Yeah, and then I was also thinking about like you're using joblib, but it's not included in the dependencies. Would that crash perhaps then if joblib wasn't included in another dependency?
Oh yeah, you're right. It's included in scikit-learn. Forgot to mention that.
Yes, I think I remember that, but I was just thinking about, is there a way like you could analyze the dependencies that is run inside the file and warn the user that, oh, you might be missing this in the packaging?
Yeah, definitely. That's a good idea. You can. We're running out of time. Yeah, that's a good idea. You could add a warning or something.
When I say no, I mean we have 2 minutes.
Okay. Yeah. Then I have only one other question. Like, does it spark some kind of emotion that it seems interesting, or does it just seem like just another library? Should I spend any time at all more on it, or should I just give it up? I'm probably gonna do it just for fun either way, but
Yeah, I do have one frank question.
How much of this is just like a tiny layer on fast API? What is that extra stuff that in the end makes this like, woo? Yeah.
the extra stuff is mostly that you, as a person, don't have to understand Docker super much to combine all of this together. And also, I think, you can dynamically generate fast APIs, as I'm doing here. Yeah, that's what I'm doing. But the main use case of fast API is not to do that. So I guess that's a little bit different.
True.
But if you have, I'm not sure I would recommend this way if you have a bigger team that can handle also a fast API stack that you can develop, and then you have full customizability. So then I wouldn't recommend it. But if you just want to get stuff out fast and want to have something to try out with, then I can recommend something like this.
Just keep it there.
Yes. So finally, thank you so much. And we have, you can find me on, my name is unique in the world as far as I know, so you can find me anywhere you want to as Erik Munkby. And also we have the QR code for the Slack that we promised. So hop in.
Thanks, Eric.
Thank you.